Boys and girls, this video is going to explain what factors and multiples are, how we can find them, and why they are useful. We'll start with factors. Factors are numbers that we multiply together to get another number. In the example shown here, 2 and 3 are factors of 6 because 2 times 3 equals 6. There can be many numbers of a factor, so it is best to keep your work very organized when asked to find factors of a number. Here's an example. If we were trying to find all the factors of 18, I suggest starting with a T-chart. Underneath the number 18, I made a large T. The first pair of factors for any number will always be the number 1 and the number itself. 1 and 18 in this case, because 1 times 18 equals our target number, 18. Then what we do is we start with after the number 1 and we work our way up until we get around the T. After the number 1 comes 2. You ask yourself, does 2 go into 18 evenly? And the answer to that question is yes. So we write 2, we write 2 underneath 1. Then we list its factor pair on the other side of the T. What do we multiply 2 by to get 18? 9. So I put 9 on the other side. Then after 2 is the number 3. Does 3 go into 18? It does. So I put 3 here, and we list its factor pair, 6, on the other side of the T. 3 times 6 is 18. Then we keep working our way up on the small side. After 3 comes 4. 4 does not go into 18. After 4 comes 5. 5 does not go into 18. After 5 comes 6. Well, 6 does go into 18, but it's already on the other side of the T, so I know I'm done. Now we list the factors always in order, separated by commas. The factors of 18 are 1, 2, 3, 6, 9, and 18. So now I'd like you to try it. On a piece of scrap paper or whiteboard, find all of the factors of 16. Pause the video until you're done, and then when you are finished, come back to the video and check to see if you've identified all of the factors of 16 in order correctly. Now that you've had a chance to try it, let's see if you did it correctly. The factors of 16, start with my T-chart. Excuse me, I know that the first factors of 16 will always be 1 and 16. After 1 comes 2, which I know goes into 16 because 16 is an even number. 2 times 8 is 16, so that's its factor pair. 3 does not go into 16, but 4 does. 4 times 4 is 16. Now I know I'm done because 4 appears on both sides of the T. As soon as you get to the other side of the T, you know that you're done. So in order, the factor pairs of 16 are 1, 2, 4, 8, and 16. Notice I only listed the 4 once. Common factors are factors that 2 or more numbers have in common. It is necessary to know how to find common factors when working with fractions. Here's an example for you. Already listed for you are the factors of 8, 1, 2, 4, and 8, and the factors of 12, 1, 2, 3, 4, 6, and 12. The common factors of 8 and 12 are 1, 2, and 4, because they appear in both lists. Here's an example. We're going to find all of the common factors of 21 and 35. To do this, we'll first find individually the factors of 21 and then the factors of 35. So I'll start with 21 with my T-chart. I know the first pair of factors is always 1 and the number itself. 2 does not go into 21, but 3 does, and its factor pair is 7 because 3 times 7 is 21. After 3 comes 4, which does not go into 21. 5 does not. 6 does not. 7 does, but it's already on the other side of the T, so I know that I'm done. And the factor pairs of 21 are 1, 3, 7, and 21. Now I'll do the same process for 35. Start with my t-chart, 1 and 35. 2 does not go into 35. 3 does not. 4 does not. 5 does, and its factor pair is 7 because 5 times 7 is 35. 6 does not go into 35. 7 does, but it's already on the other side, so I know that I am done with these factors. Now I'll list them. The factors of 35 are 1, 5, 7, and 35. The factors that they have in common are 1 and 7. Those are common factors of 21 and 35. When working with fractions, it's especially important to know the greatest common factor. The greatest common factor is simply the largest common factor that two numbers share. In the example shown here, the common factors of 12 and 16 have already been circled for you, 1, 2, and 4. Since 4 is the largest of those numbers, 4 is what we call the greatest common factor, or GCF for short. Here we'll find the greatest common factor of 6 and 9. First, we start with finding the factors of each, 6 and 9. 1, 6, 3, 3. Oops, same number on both sides of the t, so I'm done. The factors of 6 are 1, 3, 6. The factors of 9, I know I'll always start with 1 and the number itself. 2 does not go into 9. 3 does. Oh, excuse me, I have an error here. I said that the factors of 6 are 3 and 3, when in essence it is 2 and 3. I will fix that. And I'm back to my 9s now that I recognized my mistake. 1 and 9, 3 and 3, and since I have the same number on both sides, I know that I'm done. My factors of 9 then are 1, 3, and 9. As far as common factors, the only number that they share is 1, so the GCF of 6 and 9 is 1. Now I'd like you to try it. Find the greatest common factor of 5 and 15 on your scrap paper or your whiteboard. Pause the video, and when you're all done, come back and check to see if you were correct. Let's see how you did. The factors of 5 are 1 and 5 to start. Now after 1 comes 2, that does not go into 5 evenly. 3, no. 4, no. 5, yes, but it's already on the other side. So there's only 2 factors of 5, 1 and itself. 15, I know I'll always start with 1 and the number itself. 2 does not go into 15 because 15 is an odd number. 3 does. 3 times 5 equals 15. 4 does not. 5 does, but it's already on the other side, so I'm done here. So the greatest common factor of 5 and 15 would be the biggest number that is in both of these lists. I can see just by looking without listing them out that the greatest common factor of 5 and 15 is 5. Now we're going to move on to multiples. Multiples of a number are a little bit easier than factors. Multiples of a number are basically just the numbers you get when skip counting. So you find them by taking a number and multiplying it by all of the counting numbers. A lot of times people use multiplication charts to help them find multiples. In the picture that's shown here, there are multiples of 1, 2, and 3 listed. Here are the multiples of 1. You find them by multiplying 1 by the counting numbers, 1, 2, 3, 4, 5. So the multiples of 1 excuse me, are 1, 2, 3, 4, 5, 6, 7, 8, and so on. Multiples of 2 are found the exact same way. You take the number 2 and you multiply it by all of the counting numbers. So the multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16. You do the same thing to find any multiple. The thing is, you have to stop at some point. Multiples go on forever and ever. We say that there are an infinite number of multiples because you can always find another number to multiply it by. Here's an example. We'll list the first 6 multiples of the number 8. So here's 8. Now, to find the multiples of 8, I simply multiply 8 by the counting numbers. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. Let's see, that's 1, 2, 3, 4. 8 times 5 is 40. And then finally, 8 times 6 is 48. That's it. That's the first 6 multiples of the number 8. So now I'd like you to try it. List the first 6 multiples of 7. Pause the video. When you're all done, come back and check your work. Let's see how you did. The first 6 multiples of 7. 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and 7 times 6. I ran out of room up there, so put that right here. I hope you got it. So multiples are pretty simple. It's just listing out the numbers when you multiply them by the counting numbers. But when we're working with fractions, it's really the least common multiple that's necessary for adding and subtracting fractions. Just like factors, common multiples would be those multiples that 2 different numbers share. So in the example shown here, multiples of 3 and multiples of 4 are listed. The first number that appears in both lists is the number 12. So we say that 12 is the least common multiple, or LCM for short. So here's an example. We'll find the least common multiple of 2 and 5. Now, I'm going to use a couple of shortcuts. I know that all multiples of 5 will end in 0 and 5. So I'm going to list just the multiples of 2 at first, and I don't have to list a certain amount. As soon as I get to a number, a multiple that ends in 0 or 5, that should be a number that is also a multiple of 5. So we have 2, 4, 6, 8, 10. Oh, 10 ends in 0. I know that if I multiply 5 by 2, I'd get 10. So the LCM of 2 and 5 is 10. Now you try it. Find the least common multiple of 3 and 8, and after you do, come back to see if you did it correctly. So the LCM of 3 and 8. The multiples of 3 would be 3, 6, 9, 12, 15, 18. Let's see, where am I at? 2, 3, 4, 5, 6, 7, 8. Now, I know that I had to go from 3 to 24, and I multiplied 3 by 8 to get 24. Since 8 is what I multiplied it by, and that is the other number, I know that that 24 is going to be my least common multiple. Let's double check. 8, 16, 24. I just found those multiples by multiplying 8 by 1, 2, 3. 24 is the first number that they have in common in both lists, so the LCM of 3 and 8 is 24. I hope you found this video helpful. If there are things that went too quickly for you, please go back, listen to it again, try again, or ask for help. Thanks.